Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about set up a linear equation to solve a real-world application.
Minute Math, when you need help you use Minute Math.
Before we dive into an example here, there's some terms that we need to go over, okay? So I'm going to give you a verbal expression, and then how it's translated to math by operations. One number exceeds another by a, and you have x, comma, x plus a. Twice a number can be written as 2x. One number is a more than another number, and that's x, and then x plus a. One number is a less than twice another number, x, and then 2x minus a. The product of a number a decreased by b is ax minus b. The quotient of a number and the number plus a is 3 times the number. X divided by x plus a equals 3x. And lastly, the product of 3 times a number and the number decreased by b is c is 3x, in parentheses now, x minus b equals c. So here are some examples there that could help you with things later on and setting those up. So feel free to refer to that in the future. Okay, so our first example here, we're modeling a linear equation to solve an unknown number problem. So number one, example one here. We want to find a linear equation to solve the following unknown quantities. One number exceeds another number by 17, and their number is 31. Find the two numbers. Okay, so let's let our first number here, our first number they gave us, let's let that equal to x. Okay, so the first number we're going to let equal to x. And then they tell us that one number exceeds another number by 17. So if the first number is x, and the second number exceeds that number by 17, okay, well, that means the second number is whatever the first number is plus 17. So we have our first number right here, and our second number here. And they tell them that their sum is equal to 31. So when added together, they equal 31. So now we've set up an expression, or an equation here, and we can solve for x. So x plus x is 2x plus 17 equals 31. And from there, we need to subtract a 17 to both sides. We're left with a 2x here. And 31 minus a 17 is 14. Divide both sides by 2. And x equals 14 divided by 2, which is 7. We're not done here though. So the first number is 7. We want to find the second number. And they told us that that number was x plus 17. So if x is 7, we have 7 plus 17. We just substitute that in. And 7 plus 17 is 24. And so the two numbers they were talking to us about were 7 and 24, and that was the two numbers that they had asked for. Okay? So now I'm going to erase this right here. Come back with me in a second. We'll go through another problem here. So number two, we're setting up a linear equation to solve a real-world application. There are two cell phone companies that offer different packages. Company A charges a monthly service fee of $34 plus 5 cents per minute talk time. Company B charges a monthly service fee of $40 plus 4 cents per minute of talk time. Some of you don't have, most people today don't have talking minutes. It's usually unlimited, but this is back when cell phones was first coming out for me. Part A here asks us to write a linear equation that models the packages offered by both companies. So let's do that right here. So A. Well, our first company, they tell us, okay, so the plan amount, let's go the model company A, okay, can be modeled by, they say 5 cents a minute. Okay, that's a rate there. So 0.05 is our 5 cents per minute. Let's let x equal the number of minutes. And then they tell us that it has a monthly service fee of $34. Okay? Or, yeah, monthly service fee of $34. So within any given month, we put the number of minutes in right there for X, and we get the fee for the month total. The minutes times the rate, plus 34 for each month. Company B, all right, we can label as B equals, similar idea. Their rate is 0.04, right, cents per minute. So that's their X value, and their initial fee is $40. So to look at it right here, Company A has a higher charge per minute, but a lower monthly fee. B has a lower monthly rate per minute, but they have a higher monthly fee. Okay? So we've modeled both of them with an equation here, or write a linear equation for it. So number B asks us here, if the average number of minutes used each month is 1,160, which company offers a better plan? Well, the only way really to do that is, or the best way right here, is go plug in that value, 1,160, into X of both of them and see what we get. So we have Company A here, let's do that first, 0.05 times 1,160, and we're going to add 34 to that. And let's go simplify that. 0.05 times 1,160 is 58. We add 34. And let's save some space here. I'll do it right here. We have $92. So 58 plus 34 is 92. So it would cost $92 for Company A. Company B, let's do the same thing. Their formula, 0.04 that we found, and we plug in 1,160 minutes into the X value, and then plus 40. From there we simplify. 0.04 times 1,160 is 46.4. And we add 40 to that, and we get 86.4. So which one is less? We have $92 for Company A, 86.4 for Company B. Company B had the better deal. So Company B here, if we average 1,160 minutes, would cost less. All right, part C. If the average number of minutes used each month is 420, which company offers the better plan? So what we're going to do is really the same exact process as we did before. Take the equation for A, 0.05, plug in the value of 420, okay? 420 in for X, and then plus 34. And that simplifies, I'll put it over here, is 21 plus 34. So 0.05 times 420 is 21. Add it to 34, it should just fit, and we have $55 here, okay, for Company A. Company B, we're going to do the same exact thing, but with Company's B formula. Don't forget that. 0.04 times 420 plus 40 here is equal to, okay, well, 0.04 times 420 is 16.8, and then we add a 40 to that, and we get a good old 56.8, okay? Or you can put 0 if you want there. So which one's cheaper? Well, Company A ends up being cheaper here, $55. So what we can learn from this is if we're using less minutes, we should use Company A, but if we're using more minutes, we should use Company B within a month, okay? So then part D asks us this question now. How many minutes of talk time would yield equal monthly statements from both companies? Okay, so we want to find when these companies are equal. Well, how do we do that? Or how many minutes make them equal? Well, that's when A and B are equal, right? Let's just set them equal to each other. 0.05 X plus 34 equals 0.04 X plus 40. I almost put 34 there, made a mistake. Okay? So we set them equal to each other, and let's simplify. Okay, that's a 4. So let's bring the 0.04x to the left. And then we'll bring the 34 to the right. And what we're left with here is 0.01x is equal to, these cancel, and 40 minus 34 is 6. Divide both sides by 0.01, and we get x equals 6 divided by 0.01, which is 600. So what we can do is say that after 600 minutes, both of these companies would be equal. Okay? Now we can check that and plug that back into each one of our equations, and I'll just go to the first part here and just kind of do that really quickly. And basically 0.05 times 600 plus 34, and 0.04 times 600 plus 40. These two numbers both come out to be 64, and confirming that 600 minutes was the balance point. Okay, the point where they both were equal. We can see that if we graph that, and that's where these two lines would intersect. So you can see that here, that these two lines, when we graph them, intersect at that point at 600 minutes, meaning that they would be equal to each other, cost the same per month, if or at 600 minutes. Well, now you should know how to set up a linear equation to solve a real-world application. If this video was helpful to you, please subscribe to our YouTube channel and like this video. This helps us make more free math lessons for you. And as always, thanks for watching.
Minute Math. When you need help, you use Minute Math. Minute Math. Minute Math. When you need help, you use Minute Math. MinuteMathTutor.com.